and using some of that stuff over the next week. But it's all going to be very high level concepts, nothing that you have to implement in any of the projects that you're doing. And mostly just to get you a broader understanding of the Ruby ecosystem, some of the more powerful things that you can accomplish in it, and the way that somebody would do real development as opposed to writing everything from scratch like you're going to do when you're really trying to learn this stuff. But pretty much we're at about the point where I would expect the class to have reached. Teaching classes, covering that. We're going to cover, we've talked about inheritance, but we haven't shown how to do it in Ruby. We're going to talk about that. We're going to talk about some other object structures today, including composition, and the pros and cons of inheritance versus composition when you're building objects. And then we've got some nice cheat sheets here. I think Ramiro put these together. The Ruby one is very comprehensive. It's very nice. The terminal one's pretty basic, but useful. And then we'll have some extra time at the end of the class to, maybe we'll do the tic-tac-toe project together, at least so far, and get you guys with a solid base for what we're going to continue on from there. First thing I want to do, though, is review the new material that we covered in the last class. And what we covered last time was the concept of attribute properties. So attribute properties are just a really easy way to short circuit, to accomplish something with less work. It's called syntactic sugar in most programming languages. What it means is, instead of having to write out everything in the class in the complex way that you would need to do it, you've got a little bit of easier path so you don't have to do all that duplicate work all the time. There's 3 different attribute property types that you can use when you're creating properties, and they will either create a read-only property on an object, a write-only property on an object, or create a readable and writable property on an object. And maybe it's slightly misleading to say read-only or write-only. What it means is it'll create the getter or the setter for it. It's not going to create both. You could still create those independently if you choose to. Do people remember, I left them blank here for the time being. Does anyone remember what the name is for the one that creates a getter only? It doesn't create a setter or a getter and setter? Reader. Yep, that's attribute reader. And we'll have some examples again in just a minute. What about for the one that only creates a setter? It doesn't create a getter. That's writer. But the tricky one, the one that you'll probably use way more often than reader and writer, is the one that creates both a getter and setter on your property. Anybody remember the name for that one? What? Yes. And that one's misleading because an accessor should be something that creates a reader. So it's inappropriately named, but that's what it is. So we've got some examples again on a basic person object. You could create a reader just using attribute reader, like say mother and father. Might make sense to not create those as things that you can change. Maybe they're only set in the initialize method and nowhere else. You can create something that allows you to write. So I said you can change a person's mood, but you can never read their mood. It's just too hard to read somebody's mood, but you can write it all the time. And then you can create, using accessor, hair color, age, name, and that'll create both the getter and setters for them. That's just a really nice piece of syntactic sugar for creating getters and setters and instance variables on objects without having to write it all out in the longhand form. Does that make sense to everybody? Easy to understand? All right, so one other, I don't even know if I necessarily need to introduce this because it might confuse you guys more than help you out at this point in time. But we've worked with instance methods. Let me go up here. We'll bring over my terminal into here. like we've been doing. And if we're going to go into IRB and create a person, how can we create a instance method on our person? Anybody remember the syntax for that?
Object name equals person.
How do we create methods or functions normally? It's define. Def is short for define. So let's say create one that is, I don't know, what should we add to a person? Say hi. And then that might just put hello. You know, we're gonna go like Miss Doubtfire or something. So we know how to create instance methods, and that's an instance in the sense that if I go to my person class and I try to say hi, that doesn't work. Because that's not on the person class object, it's only on instances of a person. So if I create lowercase, I create a new person, then I can call that method on that person, but only on a person. However, sometimes it's useful to be able to have methods on your classes as well. So that if I wanted to do, say, person.sayHi, I would be able to do that. Because your class itself, as confusing as it can be, is also an object. It's just this class object for it. And it can be useful to have them. Some instances where it might be useful to have methods on your class are, for example, let's say you have a class, a person is a fine example, and if somebody initializes it with a set of variables, then that's fine. They can call person.new and pass those parameters in. But maybe they also want to be able to initialize it with a string from a file, and that string just has some formatting associated with it. So, you know, it could be something like this. Right? And that might just be just this string, or maybe we give it even a little more formatting so it's a little easier to understand. You might just be reading it from a file. But you already have created your initialize, and you don't necessarily want to have this format be the way that you create something new when you can pass the items in directly. So maybe you want another method attached to your person object, and that other method might be from string, for example, so that you could call, instead of person.new and passing in a set of arguments, you could call person.fromString and pass in foo and get back a person object. That would be an example of when you might want to have a method on your class instead of on an instance. Another example might be, let's say that we want to keep a count of how many people have been created. So we want to know, okay, I've created 30 people, or I've created 2 people at any point in time. That's something that you would have to have on your class because it can't be on the instance of your class. So those are examples of when you might want to create class methods or class properties. And the way that, is it a projector or is it raining? The way that you're going to go ahead and do that is a syntax very similar to what we've already used in some other places. except the location where you use it just changes up a little bit. So we're already used to these at variables. We've seen those, and those are instance properties, right? However, if you notice, the difference here is we're not using this at inside of a method. We're not defining it inside of a method. We're just defining it right on our class. By defining that at on the class object, so we can go ahead and do this. Instead of inside of an instance method or initialize, then it's going to be a class instance variable. But you only have one instance of the class, therefore it's attached to that class and we'll work with it from then on. Now, let's say we want to have a method that actually increments this count. So we know we can't just write add 1 because that would be an instance method. We've already encountered that before. However, the syntax that we have also encountered is if we're inside of an instance method, how can we get a reference to our object if we need to, say, use another method from inside that object? Does anybody remember what the name you use or what you use to get a reference to your object? Self, right? Well, we happen to be in the class right now where we're creating this instead of inside of an instance of it. So if we do self.add1, we're going to be adding it to our class instead of to the instance. So then we could do, since this method now exists on the class, if we do @count, well, it knows it's looking for a class variable. And we can increment our count. But we're not calling this from anywhere yet. So let's say we want to actually call this whenever we create a person. Which method gets called? Which instance method gets called whenever we create a new object? What? Initialize. All right. So we're creating initialize, and we want to call this class method inside of it. This is where the syntax is a little confusing, so this isn't something that we're going to have you guys implement, but it's useful to understand because we've actually encountered some class methods already in the work that we've done on some of these built-in Ruby objects. So in this case, we're calling a class method, and does anybody know how we called class methods on other objects before? It's a tough one. You use the class name. So the class name is person. And then what's our class method? Add1. We can call person.add1 inside of initialize, and that will call the class add1 method. And then we can end. Now, I've got a slight problem here. We don't have a way to read out our values. So let's open this back up real fast. Let's add a def self dot people what? Yeah. People count. And then we can just what's the count? So now, if we create a new person, I've created a person, but I can also do person.peopleCount and get out the value for how many people have been created. And if I create some more, and I go back up, person.peopleCount is 3. Now, obviously, I could mess this up a little bit, but I called add one directly now. Oh, I didn't just call it to initialize. And there's ways to protect against some of that stuff if you really want to, but this is some of the values you get from class objects. Can you think of any off the top of your head, Jorge, like examples we've encountered with class objects? I know we have. Like class methods.
Oh, class methods? I mean, yeah, we got new is a class method, right?
That new is a class method, yeah. It's one that calls the initialize of the instance.
Yeah.
It's sort of an interesting bootstrappy one. It's a little different than most of them you'd encounter.
Let's see. Time now. I don't know if you see the time class.
I'm trying to look for some here real fast. I know, I mean, one example, I believe, is puts and gets, but I don't know what they're.
You can do name. So if you have a class, and do that name, it will give you the name of that class. So you have person right now, right?
Yeah, I have person.
That name.
Yeah, I think we've done that. So we've gotten the name of them before. You could also try and find some other examples that we've called. I know that we have, and I made note of them at the time, but then I forgot. So I wanted to come back and talk about them.
How about array split? That's an instance. Split.
Yeah, I think it is. It can vary, but there's definitely uses for them, especially on the built-in objects. There's a lot of uses for them, but there's a lot of uses outside of there. I would say that what I mentioned first, that factory type approach is what that's sort of known as, is the most common.
What about file open?
File open is, I think, a great example, because if we do file.methods, it should have open on here.
Yeah, there it is. The right hand, yeah.
He's like,
There you go. Right,
There we go. So file.open is a great example. We didn't have to create a file object first. You just called file.open. And that's a class object. So it allows you to create a file. But you could also do file.new, I bet. Sometimes it's not allowed. Here it tells me I gave it the wrong number of arguments, which is fine. But that file.open, that's an example of one of those factory methods. It's something that lets you accomplish some extra work other than what initialize would have allowed you to do. That way you can have multiple ways to set up an object of a given type. Again, not something you're probably going to be writing, at least immediately, but it's very useful to know about because you're going to encounter a lot of class methods. You don't encounter quite as many class variables, but a lot of class methods you'll encounter. So are there any questions about the concept of a class method? And it's syntax that when you need to encounter it, you can probably just look it up. It's a useful thing to just remember, oh, there's methods that can be on the class. There's methods that can be on the instance. They're different. So let's go back to what we've been talking about for objects and creating them. We've talked a good deal about, let me make this larger. Make it larger and then I lose all my space over there. Ugh, I hate that. We've talked a lot about creating objects. We've started creating some of our own. And we've also talked about the concept of inheritance. as a way to share code or share logic between objects. We haven't really created anything with it yet. We might have a small example, say in the homework for this class, where we do some basic inheritance. But it's a very useful concept to understand, because the idea is that you're sharing logic between what would be the superclass and the subclass.
It's not like online where you use not the append, but like the single less than sign.
Right.
Inherit one another.
Yeah. We'll do that in just a moment.
Accurate. You see a lot of stuff
Yeah. It's a good.
Don't trust the internet.
Don't trust the internet.
Yeah.
The internet lies. No. Why did you tell me that? But inheritance is a concept, like it's a concept of inheriting behavior from a superclass within a subclass. We've talked about it. This is one of the most canonical examples is, for example, if you have a car class that inherits from a vehicle, they can share functionality. There's common behavior there because you're likely to have a lot of the same functionality for any given vehicle. You need to start it. You can accelerate, especially if you expect a vehicle to be, say, a four-wheeled vehicle that may have four wheels built onto it, and a chassis, and a steering wheel and transmission, other behavior that's shared between them.
Is it also true that you can use the include to specify a specific method that you want to be inherited? Include four-wheel method as opposed to, or as a certain other.
I'm referring to the guy who writes more Ruby code than me.
Oh, that's include is for a module.
Okay.
Include a module.
So we're going to talk about modules in the next class.
Is that way, like, if you don't want to inherit everything, you just want to inherit one specific method from it?
I'm going to say no.
No, I don't think so.
That's one of the dangers of inheritance. I could have gone into this list a little deeper, but one of the dangers of inheritance is you inherit everything. Everything that that class has, you inherit from it when you use inheritance. And so I have an example here. Inheritance makes sense in some situations, but not in all. There's a lot of situations that it doesn't make sense in. You'll find some people out there saying inheritance is evil, never use it. You should always use composition. And not a lot of people saying the other. I don't think that's true. I think they're tools. They're useful in different environments and different places. So for example, if you have a bicycle class that inherits from the same vehicle class as a car, even though at first you're thinking, well, a bicycle is a vehicle, a car is a vehicle, it probably doesn't make sense in that situation. It probably doesn't make sense because there's not a lot of commonality that a car and a bicycle share. They may have wheels and they move forward, but beyond that, there's not that much common between them, which means that if you inherited, and when you inherit, you get all that behavior, you would have to override a bunch of functionality from the base class in order to have it make sense for your bicycle, or your base class would be so generic that you didn't get a lot of value out of it. So let's do a very, very basic example in Ruby. A very basic example. If we have a rectangle class, and the rectangle initializes with width and height, and that just sets, this is a shorthand, another one of these syntactic sugar things where you don't have to have everything on a separate line. You can do width and height on the same line, and Ruby will look at this line and assign the width to the first item, the height to the next item. That's just a quick shorthand so that you don't have to write everything out independently. So don't be concerned with that new syntax. And maybe you have an area method that will return the area of it, which is width times height. Now, if we have a square is very similar to a rectangle, but even simpler in some respects. So you could just inherit, and that's what this arrow means, this less than symbol. That's used for inheritance. So it's saying I'm creating a class square, and it's inheriting behavior from the class rectangle. And then it overrides, that's the term used when you change the way something works. It overrides the initialize method. So when you initialize a square, you only have to pass in a width, which we'll call using this super. This is a lot of syntax that we're introducing here. And I'll whiteboard some of it out to show you sort of what's going on the objects. But that's going to call the initialize of the rectangle object, and you get access to that using super. Super because it's the superclass of the object that you're working on. And then that will initialize. So if we go back up and look at our rectangle object, well, if we call initialize, that expects two parameters, width and height. This is really easy. We had a width, we just pass it in twice, and it becomes the width and the height. Now, the great thing about this square object is it also has access to the instance methods. So when we create these, and we'll go ahead and create these over here in Ruby. I'm going to write this out in the long form just so that you guys can see that it's the same thing, because we're familiar with that syntax, right? That other one is just a shorthand.
I think like the Ruby community prefers that.
The writing out longhand. Most communities prefer it that way because it's easier to look at all of your items. So now, did I forget to open up my class? I did, didn't I?
Yeah.
I think okay. Let's see. So let's create a rectangle of 3 and 4, rec.area 12. And now we can create our class of square, and it's going to inherit from rectangle. But we want to change the way the initialize works, because we only need to pass in a width for a square. However, to make our life easy, instead of recreating the area or setting our own instance variables, we'll leverage what we already have from our rectangle. We'll pass in a width, and we'll pass in a width. And then we'll exit. So now we can create a square. And the great thing about this is it has access to that area method. And it has access to that area method not off of the square object itself, but off of the rectangle object. So if we did square dot instance methods, or we did sq.methods, should be the same thing, and we look at the methods, we'll see that we have an area. Fantastic. But remember, we can do this very basic, it's not perfect, but we could do sq.methods minus rec.methods. And we'll see, that square object class, that added nothing unique to it. So we lost our area method. That was being inherited from our rectangle object instead and calling down into it. Does that, at a very basic level, make sense so far? It's a little confusing. So it's a little hard to explain on the whiteboard, but I think I'm going to try. Have a marker over there. You got some others. Oh, cool. whole stack. They were just hiding them.
Ninja markers.
Here we go. Go on eraser they have. Yeah, somebody drew this amazing bowl. I'm gonna erase that though.
It's by Caitlin.
Somebody came here and sabotaged the Raleigh campus by saying Durham rules. How cool.
Almost positive that was Caitlin. She's known for drawing on whiteboards, and she lives in Durham.
Well, there you go.
The clues are strong.
So if you want to think about what's going on here, is we've created this rectangle class. I'm so lazy, I'm not going to write it all out. And it has an initialize method in it that does some stuff. And it also has the area method that does some additional stuff. And then we've created a second class here, which was square. And in square, we created an initialize method. And in it, we do some stuff, and one of the things we do is we call super. Passing something in, and then we end. And this square object, one of the key things is it inherited from our rect object, our rectangle. So what that means is when you create an instance of this square object, it's going to go down the entire chain of its inheritance, and it's going to make sure that it has access to all of the variables, the methods that exist in these other objects in that chain. The way that I can call them if I'm in one on square is I can use super. And that will call the superclasses method. So in this case, initialize, called super, and it gets the initialize of this. However, the key part here was this square object, like I said, has access to everything from these other objects. So when we called sq.area, what's actually going on in the computer is it looks in this square object and it says, do you have an area method? You don't. All right, there's no area method on you. I'm simplifying this because we're going to talk about how there's more to it than this in the future, but then it goes, okay, no area method on you. What about on your superclass? Oh yeah, there's an area method on that. Okay, we need to call that area method. And it'll just keep walking down the chain looking for some class in the inheritance chain that has that method until it finds the first one it encounters, and that's the one that it's going to call. Now, if we talked about, already have an example using initialize, how we can call down to the parents method or the superclasses method. So let's open our class square back up again. Even though this is sort of ridiculous, let's create an area method inside of it. And how are we going to, but we don't want to actually redefine it. So how can we instead just use the, call the super. So you can call it just using super. So now, the interesting thing about this is we're no longer actually calling mapping directly down to this area because we went ahead and created one in our square object. So it's calling it in the square object now, And then we are deciding to call down to the area in the superclass ourselves. So if, say, we wanted to add some additional logic at this level, we could very easily do that.
I think Sandy West, the way she puts it is like this sort of a question, right? Like you initiate a question to an object, and it goes up the chain to see who answers that question.
Yes, technically, and I haven't used this terminology here, so I don't know if I want to introduce it, because even though it's the right terminology, I still don't even feel like it's that common even in Ruby community, is it's known as message passing. I don't know.
Yeah, it's just a proponent of that.
It's terminology that I didn't encounter for a long time because I just called them methods and functions.
Right.
But it's known as passing a message. You're not, what's going on under the covers is you're not necessarily directly invoking the area here. You're passing a message to your square object saying, here's the message, give me an area or do something with this area. And the square object knows how to handle that. And when it can't find it here, it says, oh, all right, let me check, farther up the chain, etc.
See who understands the question and
Yeah.
who can provide the answer.
That's good, yeah. See who understands it and provide the answer. And you may have multiple levels of it that can provide the answer whenever you create something like this. So I'm trying to think of another good basic example. We could go back to our person. We have a person. We can create something off of that. Let's change the initialize for our person. Pass in a name and an age. Let's say. And then let's add some other method again. Let's add I can't remember if I spelled alcohol right.
Yeah, that's right.
So this will, let's put some basic logic in here. If age is greater than 20, but drink responsibly. Else, but get out of here. And all right. So we've added something to our person object. But let's say, for example, we don't always want to specify all of this. Sometimes it's just more work than necessary. So let's create a teenager object. In this, we can override our initialize if we want to. But we're still going to want to pass in the age. There's no reason to override the initialize, and name and age still makes sense. But it might make sense if there was, say, a lot of complex logic in that can buy alcohol method. Well, I don't need all that complex logic. I can just say, get out of here right away. Forgot to have my class teenager inherit from a person.
Well, I guess it would be good to try it without it, right?
Well, it's going to work, but the initialize wouldn't.
Right.
So if we have John, let's say, and we try and create a teenager, new.
It's not just teenage.
Teenage. Oh man, look at that! It screwed it all up. Forget this. That class doesn't exist anymore. Good. Just gonna inherit from a person right away. Okay, so now we can create a teenager. If we did this, it should yell at us. And does that make sense why it had a problem? Because if we come back over here, and we're going to change these. These aren't square and rectangle anymore. This is now person and teenager, if I can write. So what method did we define on teenager? What methods does teenager have right now? Can buy alcohol. All right.
Did you call the
And-
other class and then you could use it? Maybe?
And what methods does our person object have? It has can buy alcohol, and it has one other method. Anybody else? Other method on it? Initialize, yeah. And the initialize here takes two arguments. Now we don't have any defaults for them. So it takes a name and an age, right? And our teenager inherits from a person. So we're talking about the behavior that happens. When we call teenager.new, that will call initialize on our class, on our instance. So we call the instance methods initialize. But does the teenager have an instance method of initialize? It doesn't. So it looks here, it says, oh, I don't have an initialize. So I need to call, check and see if the super knows how to initialize. Okay, it does, but it expects two arguments. It expects a name and an age when I initialize. And that's why when we tried to initialize just now without anything, it failed. Because it was expecting a name and an age when it called the super classes version of it. Which means, all right, we need to pass in a name. We need to pass in an age. Now we got an object. And it worked correctly. If we look at the methods on it, we can see right there at the top, we have that can buy alcohol method. We also happen to have say hi. Hey, remember we defined that on our person object earlier as an instance method. So we have that as well. This one we've overridden. That's what it's called when you, in your class, override the behavior that you would have in your superclass. Say hi, we haven't. But now, one difference is if we did non.methods minus person.instance methods. Oh yeah, I forgot. This is just shorthand. It's just doing array subtraction, so it's not going to actually work the way I would expect. Since it exists in both, it's going to get subtracted out.
Yeah.
But I think you can do self methods or something like that. Let me look here.
Because they're named the same, right? It subtracts them.
Yeah.
The place you can't drink alcohol, right?
Oh yeah, he's definitely not going to be able to. That's for sure. But can buy, right? Can buy alcohol. Get out of here. But the difference is if we create now, create Jared again. And he has a name. And he has an age. And here's Jared dot can buy alcohol. All right. And we could also do, we're not required to create a teenager, so using the teenager class. Susie is just, I messed something up.
New.
Oh, new instead of name. So I should change these so that it's clearer here. I will. Can buy alcohol. Puts. I know a fake ID when I see one. So now there'll be different messages. So John, since he is from the teenager class, we try this now. Yeah, I know a fake ID when I see one. But Susie, even though she's a teenager, it doesn't matter because she is a person object. She didn't get created off that. We'll get the other message, the more generic one for the person class.
Yeah, you can have like a teenager classic point.
Oh yeah, teenage.
Yeah.
Yeah, teenager wine.
Yeah.
Like, stop telling me what to do. I'm an adult. This is crap. Waste of my time. Ugh. I'll be on Instagram. Does this make sense? How that's working? We'll talk more about it in the last couple classes. We'll continue to go over this a little bit. But does the sort of concept of how a class can inherit behavior from other classes at a base level make sense? Yeah. Awesome. This is a very fundamental concept in object-oriented programming. But as I said before, there's a lot of times where inheritance doesn't make the most sense. It's not necessarily the best tool in a lot of situations. So let's talk about another very, very common tool. And a lot of times they're marketed as if they're opposed to each other. I don't think that's true. I think they're complementary to each other. They work well together. And that is composition. Composition is the concept of creating an object composed of multiple other objects. So we've talked about this before. We talked about, for example, if we have a car object, what are some objects that compose a car? So what are some objects that a car is composed of? An engine, wheels, brakes. What about a chassis?
Yeah. So, I don't know what chassis is. So
That's the underpinnings piece, the stuff you don't see.
It's like a skeleton.
Yeah, it's like the skeleton of the car. Yeah, that's exactly what it is. So a car is composed of whatever, of these different objects. And if we just, I wrote the car with a capital C because it's an object. So now let's think of these as objects too. So the engine can be an object, and wheels can be an object, as can brakes and chassis. This is also a very, very common pattern in object-oriented programming. The concept of composing an object of other objects. So I had, for example, up here, a car might be composed of wheels and an engine, chassis, doors, windshields, transmission. There's a lot of different pieces. So if we're trying to create something that way, one approach you might take is, here we have our car. Let's create a car class. And inside our initialize method, we're going to create an engine instance variable, which will be a new engine object. And we're going to create a transmission instance variable. And that transmission is just a new transmission that we dropped in here. And we're going to create a doors array instance variable with a left door and a right door. This is just a two-door car. And anything else that you want to create inside of there, you can initialize those objects and create them inside of your initialize for the object that you're building. That's the idea of composing your object of other objects, so that instead of having to have all of the methods and all of the properties for an engine and how an engine works inside of this car object, those can be encapsulated in the engine object, and we might just need to write some wrapper methods to access some of that functionality from the car. Or maybe you never access the engine directly, because if you're working on the engine, you get the engine object. The engine is used when, say, you start your car. Well, that performs an action on the engine, along with performing an action on the transmission, along with performing an action on the brakes and some other aspects of your car. Like I said, these are frequently said as opposing each other. I don't think that's true. I think they're complementary, but composition is definitely a favored approach to building objects because of the flexibility that it provides for you. You can compose it with a whole bunch of much smaller objects, and that gives you a lot of flexibility on what this car object looks like. Because in this case, I'm initializing an engine.new directly here. But for example, if I did this a little differently, and this won't work because I haven't created these, I could create an engine externally. And then I could do like an IRB. I could do an engine externally, and maybe it's a V8.new. And then when I have my engine object, then when I create my car, I could do, say, car.new and pass in an engine, the engine that I had already created. That way, I can build my car out of whatever components I want, and I can build those components separately and then put them together after the fact to make my car. So it can have a different engine type, and it doesn't have to be declared inside of it. The flexibility this provides for you when you're creating objects is one of the big benefits of doing a composition type approach over a inheritance-based approach.
Now, but then you don't have any arguments, right? So you would have to add it to initialize.
Yes, I'd have to add it. Yeah, none of that's working.
That was like pseudo.
Yeah,
Gotcha.
I was just throwing some pseudocode up there. I'd have to have those arguments in the initialize so that it could accept them.
Yeah.
Oh, I take an engine object, and I take And that would be a common pattern. You might create a class of car, and the initialize might take an engine, and transmission, and wheels, and doors. That way you could pass those already created objects into it, instead of having to create them within it.
An object question. So, I mean, and things better mechanics. You could have the object creation, like initialized inside of a file, right? But then you put the object in another file, it seems to lose object. It's like it doesn't have separate attributes anymore. And if you bring it back in, it just treats it like those parts of it. It's a string or just not.
I'm not sure I follow. Are you talking about when you're writing out to a file?
Yeah, like if if it, as long as it stays, as long as I keep the object within the file where the initialization of the object is, the code that initializes the object is, it's fine. Once I take it and put it somewhere else and then later bring it back in, it doesn't know how to read it as that same object.
And when you say put it somewhere else, you're talking about, say, writing out to a YAML file or something.
Yeah, and then bringing it back in. So
Right.
that's something I should do to let it know that those are still, that this is still an object.
So the key there is reading it in and creating new objects when you read them in. You have to recreate your objects. It's never going to maintain the object information when you write it out to a file, because that only exists within that Ruby code, that Ruby environment. Once you've left that Ruby code,
With all the same attributes.
you'll have to write all of those attributes out and read them back in. So all of the attributes that you want it to recreate it with have to be written out to your file.
They're written out, but when it comes back in, I don't see how.
So you're talking about persistence, right? Persistence of
Yes.
Yeah, it loses its objectness. And that's probably not, that's not the correct term.
No, I think that's fine.
Like, so if I bring it back in, it still has all that information, but it doesn't associate it with the attributes that they should be associated. It just strings now. It's not values for attributes.
Right. The key there is making sure that you initialize it correctly. So it's the key is making sure that when you initialize your object, you handle it correctly. And that's why, for example, I just talked about, say, the factory, why you might have a class method. So if we had on our class of person, and we define a self.fromString method, on here, we may need to, let's say it's a comma. Does split work with commas by default?
Yeah.
So let's say it's a comma delimited string, and we'll get 3 values out. Then we need to know what we want those to be when we write them, when we're creating our object, which means we could do.
Wait, I'm sorry. Split is space. I believe. The default.
Split is space?
Yeah.
Okay, well, we can use spaces, it's fine. So let's say we've got this defined. Like I said before, we're gonna have a name and an age, just the space between them. And we'll pass this in as a string to create a person. So what we need to do here is let's do data equals string.split. So now that should be an array of our properties. And we said it's going to be name and age. but there's still going to be strings at this point in time. Just like if we get user input from the console with gets, we're getting a string, even if we want a number. But we don't want that to be the case on everything. However, what we're trying to do here is create a new person. So we're going to go ahead and create our person. We'll do person.new to create a person. And we know how to do this. We can pass in a name. In this case, can just be data of 0, the first item in the array. And we also want an age, but we want the age to be a number and not a string. But we know that data 1 is going to be a string, so we can do a 2i to make it an integer instead of a string. And so now we have a from string factory on our person. So now I could do Jared equals person.from string and pass in a name and an age, and I get it back out the way that I expect it. So
It's really good, and I know I've been out for years something else, but it's saving it as, like, it would be saved as Jared, parentheses, name, with the colon, with the name there, and then so the name, age are in that string, they're part of the string too. They're saved to the file. It saves the entire thing. So it's not like just a number, comma, or name. It's like the attributes they're associated with, name, and then what the name is, age, and then what the age is inside the file itself.
okay, I think we'll have to look at what you're talking about in order to understand, but the same approach works. All you have to do is know what you're reading, the format you're reading, and know the format that you want out. And all you do is you read it in and convert it to the format that you want to create your object.
That is really helpful. I just have to figure out how to change what it's saving it as back into the object.
Well, potentially. I mean, you're probably fine with whatever it saves it as. The key is just reading it back into the object correctly. So unless you're missing data that you saved out, as long as you have all of the data, you're going to be able to recreate objects off of it.
Okay.
Are you using toString or toS on your object to write it all out?
Well, it's just saving it as it has it in a hash, so it has a key, and it puts that in the file, and it says the key equals value, which is the name of the album, and then parentheses name for the attribute, and then the actual name of the album, then comma, artist, the actual artist name, comma. So it puts like the attributes in there too. And I thought I was thinking maybe if I put the at symbol up in front of them, if I brought it back in, would it recognize that there was, I did do the attribute assessor for them at the top of them.
I don't think that's going to work. And if it did, it would
Just
be,
bring it back in as a string, right?
yeah, it would be a result of some Ruby magic that was doing something magic behind the scenes for you.
I just wish it would recognize them.
We can work through that in just a moment.
Are we gonna discuss bringing in initializing objects of another class?
Well, that's what we just showed.
Yeah, but like that's just the engine not do it. Like it doesn't show like what happened in the engine class. It's like I have.
It doesn't matter.
Well, because I'm trying to do the initialize with the tic-tac-toe board, but it's not.
Right. So let's go ahead and do that. Let's work through that together, or at least try and work through that together. I don't know how this is going to go, but let's try and create this. What did I say? We want a board, right?
It is a square.
And we also want a square object, right?
Initially, what is add the square first?
What's that?
Add the square first.
Maybe, but probably not. It probably doesn't really matter. It would only matter if you referenced the square before it got to reading the code to recognize that the square existed. Otherwise, it's not going to matter. All right, so we wanted to create, look, I don't even remember what I gave y'all.
We're supposed to create a square that has one attribute of value that's set to an empty string. And do a setter and getter for that. Which I did with that.
All right, so we wanted to initialize the squares, right?
Yeah.
So let's do the simpler one, which is a square.
Yeah.
And in it, we have a value. Let's go ahead and use, let's use our attribute property approach, which was attribute accessor, right?
And then,
Is it colon?
yeah.
Colon square. So that created our,
Colon value, right? That's what we're calling the value.
oh, colon value, yeah. There you go. So we're creating it. Now let's go ahead and initialize it. We want it to be an empty string, right? People with me so far on this square? Okay, so the square is pretty simple at this point in time. Let's give this let's try and just test something out. Build our code bit by bit. Square.new. Let's put square.value and just see what happens if we run this code. So we'll go into our examples. We'll do Ruby, tic-tac-toe. All right, looks like we probably got an empty string. Let's put something in here just to make my life easier to confirm it. Our square object looks like it's putting out the value that we have in there right now. That's pretty simple. Then let me pull up what I was asking here. Ugh, go away. Too much. Maybe I can look at this in more detail. So I said we've been learning about classes. Let's build something more complicated. Create a board class to represent the tic-tac-toe board, and we will create a square class to represent each of the 9 squares on the board. The value attribute should have getters and setters defined for it. That's inside of the square. The board class should initialize 9 squares when it is created. The board class should have a show method that will display the board with the value in each square. When the show method is called, the output should be similar to below. All right. So let's continue to build this. Our board needs an initialize. And here we want to create 9 squares. I'm gonna throw a comment in there right now. I don't know what that means. And we also happen to want a show, which will output a board of the 9 squares. Okay, sounds reasonable so far. Let's go ahead and step into our initialize here. Let's do this. Let's just act like we don't have to be too fancy. We can do this in the most basic way possible, right? So we need to initialize 9 squares. How can we do that?
Although I declared it as the next one.
At square 1 equals square.new.
Do you have to put them in the parentheses next to initialize? I did do
thinking like parameters, pass through.
Yeah.
You don't have to necessarily because he's doing it inside the initialize.
You could pass them in, or you could, we can show both approaches. So we can just write them out like this, right? This is a little tedious. I'm writing out a lot of squares. I'm gonna have to reference each one individually that way. But it's a perfectly valid solution to the problem. There's nothing wrong with it whatsoever. You could also, if you wanted to be, there's no right or wrong answer to the way that you would set this up. So maybe we do it by rows. First row. All right, let's create an array of objects for the first row. So how can I create an array of square objects here? Square.new. 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 All right. Square.new. 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 This is a perfectly valid solution to it as well, where maybe it's got a little more structure, a little more of what we're looking for from the board structure with this approach. And we could make this a little easier. We could shorten the writing. We could use an array of arrays to handle this if we want to. But this is just as valid as anything else. So we've created this, all right? Now we want to go ahead and output the board. So well, the first thing we know that we want to output the result of the squares, right? So we can, even if we're not drawing stuff in between, we could do,
I did.
but at first row 0, I guess you would need to put them together, right? At first row 1, at first row 2. Let's see what happens. Let's just test this out at this point. So we're not going to create a square down here. We're going to create a board. Board.new. And then let's call board.show. All right, well, I've got a problem. Oh, I know what it is. I used uppercase B here. I was trying to refer to the show class method instead of the instance method. All right, and now it's yelling at me because, oh, hey, I don't know how to.
You can do a range. You probably can do that first row range 0 to 2.
The first row range is 0 to 2, like puts the range. Well, one of the reasons it's yelling at me, and I think this will still work, the range stuff is really cool in Ruby. I'm not as familiar with it because a lot of languages don't.
You can do it like that. That's graphics.
Can you also?
Yeah.
Nice. It's still going to yell at me, I'm pretty sure. We'll see. Oh, no, it didn't. But it's definitely not what I was looking for, is it? I printed out 3 square objects. Well, that's awkward. So how might we solve that? Any suggestions on how we can get around that? What do you think happened? Why did we see these 3 Why is this our output? What's that?
Do you need to define a 2x?
No, we're getting somewhere. Let's try this. What if I create a square directly again? Square.new, and then I did puts square directly. What's the result we're going to get? Let's see here. Well, it looks like I got that same thing out, right? Because when you do puts, it's putting a string, which means it's going to try and convert whatever you have to a string, and the default behavior for 2s on an object is like this. Now, we could give our squares a method to, I mean, we can access the value. So if we want to, I don't know if this works. Is this syntax going to work? That's pretty crazy stuff I'm doing right there. It's like, you're crazy, man.
Yeah.
So we'll go back to our other syntax for a moment. This is longhand again. But what we can see is, well, we know the values. Those are something that Ruby knows how to convert to a string because they're strings. In fact, let's show that by initializing to something here. So it'll be more obvious. It says empty, 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 because we're spitting out the values. So that's one way we could do it. You also touched on another way. You could override the toString method if you wanted to, for the 2s. So it just returns the value. And then we could take this syntax and go back to what we, had just a moment ago, which was puts first row so now that works, but there is something funky about it, which is it's putting each one on its own line. And we're wanting to print them out all together. So it's not quite going to work because of the way that Ruby is handling the, you could, yes. Because of the way Ruby is handling this is it's calling it each time. But if we did print, that should, that was crazy. Print doesn't do 2s. Print does something different. See? That's very interesting. But let's keep it simple. Let's keep this thing as simple as we can be. So let's go back to our long complex syntax that we had here. All right. And what did we actually want as our outputs? We wanted some pipes between our things so that it looks like a tic-tac-toe board. All right, we know how to do that. Let's just put something here between them. Now, one thing I'm going to do is I'm going to change this to be not an empty string, but one empty space. That's just me letting stuff space out correctly so that it's not all collapsed together. First row 1. Oh, again, let's need to get the values off these. Right? Dot value. And then we'll add in our other item. And you could do first row 2. Dot value. Now let's test that out. See what happens. We don't want this code anymore. All right, we're starting to look correct. But once we're done with that, we want a line that's just a bunch of dashes, right? Starting to look like a tic-tac-toe board. We're getting there, we're getting there. Now, I'm gonna be lazy. I'm gonna copy this guy here. I'm gonna do it a second time. I'm also going to copy this line right here. Oops, this isn't at the right point.
I put self instead of the.
I noticed that.
Yeah, and when I changed it all to the A circle thing, what do you call it? Whatever it is.
This is very,
Instance variable.
Yeah, now it works.
All right.
she was updating the attributes on self.name and self.so.
Right.
instead of the instance.
I got it. So there we go. We got a nice tic-tac-toe board out. It wasn't that much code, but it let us get familiar with classes, get familiar with composition, where our board here is composed of these squares. Our board's gonna have, we're gonna add some logic to our board for this next class. I'm gonna go ahead and post this, but I'm gonna simplify it a tiny bit before I do. So you guys will have access to this for the homework for next class to start from, so you don't need to worry about making sure you get it all right now. I'll include this. Being a good lazy programmer, I wouldn't type this out 3 times normally. I'm too lazy to do that. I'm doing the same thing for each line. Why would I do that? Let me just create a def show line method, and it's going to take the row, or show row. It's going to take the row array in. I'm properly lazy. I'm not going to do this stuff repeatedly. So now I can put at row 0 value plus my pipe symbol plus at row 2 dot value plus pipe plus, oh, it's not at row here. See, this is a variable in my, that I passed in, not something that's an instance variable. So row dot 3, 2, see, look, I'm messing everything up. You guys get to see someone really screw stuff up live. Row 1 dot value. And now I can be lazy here, get rid of all that, and instead call show row with at first row. This can be replaced with show row at second row. And this one can be replaced with show row at third row. Is that gonna work? We'll see. Give that a go. Awesome. That worked just fine. Now, that should be a tiny bit confusing because we didn't do self.showRow, but I think it was able to figure out, since I used the method with parentheses, that it didn't need self. Ruby, I think, is
Yeah, Ruby has.
Ruby's smart enough to know, oh, this can't be a variable. So it must be a method on myself. But I wasn't 100% sure that Ruby would do that. That was some Ruby magic. To make sure you know what you're calling, I would suggest doing something like self dot. Okay, I know what I'm doing here. I'm calling the show row method that's on this object. Does this make sense to everybody so far?
So I need to use the instance variable indicator instead of self or the
Well, I think like the difficult part is keeping in mind the scopes, right? Because what you had was def self show, which is not the same as self.show inside of a method. Two different levels.
Right. Yeah, next class I want to go into more detail on scope, and then I also want to talk about modules, which is another way to compose methods onto objects using modules in Ruby. And we'll talk about scope, because if people remember, we talked about scope when we introduced functions, and how you have local scope inside of your function, and it only has access to those variables that are in your function. You can't access the function variables outside of that scope. Scope gets much more complicated. You add another layer on when you introduce classes and objects. And we'll talk about the complexity of scope in a class and object model.
I misunderstood it self as being the same as the instance indicator. I guess different things, like one is for calling more of the class itself or something,
So
and the other one for the objects within it.
I'm gonna go ahead and stop my